the column, and if you are looking the rows containing the values 1 3 5 9 11 13, here 1 3 1 3 5 9 11 13, same here 1 3 5 9 11 and 13. Let me check here. 1 3 5 9 11 13. In this table 1 3 5 9 11 and 13. Also here 1 3 5 9 11 13, and at last 1 3 5 9 11 and 13. So here the first is, I am using the highlighter to indicate this. Here this row contains the values 1 3 5 9 11 13. Also this row contain 1 3 5 9 11 13. Also this row contain 1 3 5 9 11 13. Also this row contain 1 3 5 9 11 13. Also this row contains 1 3 5 9 11 13, and here this is the row containing 1 3 5 9 11 13. So you can simply see this is the point here: 1 3 5 9 11 and 13. So the only rows that contains A1 are for the values that are relatively prime to 14, 1 3 5 9 11 and 13. For the multiplicative inverse, one way of finding the inverse of A modulo M is to extend Euclid's greatest common divisor algorithm. The extend Euclidean algorithm, while computing GCD AM, we can also find two integers u and v such that GCD of AMM equals UA plus VM. If A and M are relatively prime, then the GCD of AM equals 1 and 1 equals UA plus VM equals UA mod M. Performing a reduction for mod M and then multiplying both sides by a to the power minus 1, then a to the power minus 1 equals UA into a to the power minus 1 equals U. So if GCD AM equals 1, then U is the multiplicative inverse of A mod M. Otherwise there is no multiplicative inverse. So this is also important point.